Hello, manufacturing world. I'm Wade Anderson with Shop Matters, sponsored by Okuma America. This podcast is created to discuss all things machining and manufacturing. Today, we are going to be talking everything you need to know about work holding. Joining me in the studio today, I've got a guy. I'm going to back up a little bit before I introduce him and tell you the story about how I met him. So, so this is where I say it's important to talk to strangers. And I know as parents, we always teach our children never talk to strangers. But I got a voicemail from this guy, and it was very dry. It was just, hey, Wade, I'm with a work holding company. Heard you manage the Partners and Think at Okuma. Give me a call. By the way, I'm friends with Bob Elsey. And I first thought, wait a minute, Bob Elsey doesn't have any friends, so this, I got to get to the bottom of this. So
that is true, by the way.
I guess I'll find out if Bob's actually listening to this podcast now.
We'll find out for sure.
So joining me in the studio today is Jason Bateman from Jergens Workholding. Welcome, Jason.
Thank you, Wade. I'm happy to be here today.
All right. I'm glad you're here. I've been around Workholding for a long time. Actually started one of my first jobs when I got into working for an OEM machine tool builder. I worked for another machine tool company for a while before coming to Okuma. And a big part of what I did was process development work, and I made a lot of my own fixtures and work holding. So this is a topic near and dear to my heart, something I really enjoy doing. And Jason, I've worked with a lot of work holding guys, but I got to say, by far, you are one of the most knowledgeable guys that I've ever dealt with.
Appreciate that. Thank you.
Tell me a little bit about how did you get into the manufacturing world? How did you get into this industry?
Well, I think I got more forced than anything. What I mean by that is Dad started a tool and die business in the family's garage. And out of my siblings, I was the only one that really participated. So that was sort of a forced training program, if you will. Dad would plug me in with one of his die makers, and that would be my tutor for the next year or something. So it was those kinds of experiences and working with those kind of guys that really developed a lot of depth for me and exposed me to a lot of things. So as painful as it might have been at times, I really, looking backwards now, really value those experiences. They were really pretty neat.
That's awesome. What do you see? What are some of the biggest trends that you're seeing right now in your industry? In the side, when I say industry, we're all in industry together, right? Mm-hmm. But in the work holding segment of this market space, what are new things? What's stuff that Jergens is working on?
So one of the things that is all the rage at the moment is how to process 5-axis parts. So everybody's got interest in how do we hold it, how do we get density now. People want to do density in the 5-axis environment. It used to be just one piece. Now people want to do density. So we're getting a lot of inquiries on how that comes into the viewfinder.
So let me hit the pause button there. Explain density a little bit more. Let's peel that onion.
Sure. So, in the normal, I should say normal. It's not really normal. I guess it's the vertical milling arena. You'll have a tendency out there to purchase this 40 by 20 machine, let's say, and usually we'll put like a vise, maybe 2 vices on there. But if we take a look at that for a minute, and I throw this at customers a lot, is what got 800 square inches of table there. You put on a vise that really, at its best case, could hold 42 square inches of something, right? Well, you still have the rest of that table. So your spindle utilization and your table utilization is next to nil. So what we coach them up on is how do we take advantage of the rest of that space? So therefore, the density conversation comes into play. So we start working on how many pieces can we get under spindle? How long can we keep that spindle running without interruption? Because it's only when your spindle is running and making chips that you're making money. You're not making money when you're changing fixtures. You're not making money when it's doing tool changes. You're only making money really when you're cutting chips. So density. So that concept really has not migrated into the 5-axis environment until just recently. So a lot of folks are going, hey, I want to be able to take and put 3 or 4 parts on the, say, like a flower type fixture or a multifaceted fixture, so I could process 4 parts at a time. Or possibly it's, I want to do 2 op 10s, 2 op 20s kind of thing. Or we've even seen customers now ask us, hey, is there a way we could build like a little tombstone that would fit on our platter? So those are some of the density conversations that are starting to occur around 5-axis, which until recently wasn't really a conversation.
Okay. Back years ago, I used to do a lot of the work holding I did were for grinders. I did a lot of work on 5-6-axis super abrasive grinders. Mm-hmm. We would use a base plate setup where we would take them in and out of the machine really quickly, and then we'd put the work holding piece on top of the base plate, basically.
Sure.
So that's something that we were doing quite a while back. But I don't see us doing it that much, even internally at Okuma. Here,
Correct.
It's probably been a year ago or so, I got asked to come and speak to a group with the NTMA from their work holding division at the NTMA. Great group of guys. I'm trying to think, okay, what do I do to present to guys that do this every day? So I did a piece on quick change. How do we get better at utilizing quick change tooling and reducing our setup times? And wanted to get some examples to pull together some PowerPoint material. And I walk out, I've got an M560 sitting on my showroom floor there at the Partners in Think building. And I'm going to go out and take pictures of that, use that to start building my PowerPoint. And I open the door on the machine and look, and I've got a vise on the 40-20 table, one vise with one part. And it looks like the vise was probably pulled off of a knee mill somewhere. And I'm just thinking, my gosh, I'm my own worst critic, right? I'm the guy that I'm usually talking about that this is not how you should be processing parts, and yet I walk out on my own machine, and that's how we had it set up. So currently, in the Partners in Think building, I've got 2 M560s, and I've got one of your base plates along with your ball lock system. Mm-hmm. Talk a little bit about that and tell the audience listening, what do we have set up and some of the tolerances. When you're pulling stuff off, putting items back, what can you expect from a tolerance standpoint?
Certainly. So, we talked about this real estate piece a minute ago. If you consider that, you take a 40 by 20 machine and you look at that 800 square inches and you look at the fact that you could have possibly spent $130,000 on that. That comes out to right around $160 a square inch is what that real estate on that table costs you. Now, if we convert that to square footage, that's some really expensive square footage. That's way more expensive than any building square footage that you could buy. So why are we not utilizing it better? So that's where the ball lock system comes in, and it's interesting. I'm always amazed with ball lock. It's actually been around since the late 70s, and there's so many folks that have never had an opportunity to really work with it, understand it. And really what it does is it provides a foundational element for users to quickly and very repeatably take their tooling on and off their machine tool. It's really, as we like to talk, one of the first steps in the automation staircase, really, because in automation, of course, there's tons of definitions of that, but what we see is that you're really eliminating variables when you start getting into automation, and really that's what the ball lock system does, is it eliminates variables because it gives you defined locations that you can mount and dismount repeatably your vices, your fixture plates. You can make adapter plates, and we can actually provide a foundational element to allow really anybody's work holding at the end of the day to be quickly and rapidly taken on and off the system. So in terms of accuracy, we look at a 5/10 repeatability when we're taking fixture plates on and off. We typically will configure the table, has the receiver piece in it. The fixture plate is going to have in 2 corners precision locating bushings, and then in the opposite 2 corners, so we don't get over constricted, it's typically going to be left opened. So we really have a primary liner, and you can play with this however you like, but typically we put the primary liner in the lower right-hand corner. We put the other liner up in the upper left-hand corner, and then, like I said, we leave the opposite corners open. And this affords us the ability to locate and repeatedly position plates, whatever that item might be, on and off the table. So, it's handy for things like rotaries. Right now at the Think facility, we have the machines with the rotaries on them. And if those of us that have had to install rotaries, we know that when we take that rotary off, we're always thinking in the back of our head, this is going to be tough, because now I'm going to be spending at least a couple hours indicating this thing in and clamping it down and going through all that stuff. So here we have a situation where we have a fixture plate mounted to the bottom of the rotary. That fixture plate has a pattern that matches a pattern in the subplate, which is mounted to the T-slot table. And all we have to do now is remove 4 pins, remove the cables from the bulkhead. It actually takes you longer to probably find the tow motor or the crane to take that rotary out of the machine. And then when you go to put it back in, it's literally rewind that process, 4 pins, attach your cables in the bulkhead, you're done. So the ball lock system and that kind of thing really affords us the ability to manage variables and do it repeatably and accurately.
So that's something that really, I look at it, attacks efficiencies, right?
Yes.
So you touched on earlier, machines are only making money if they're cutting chips.
Mm-hmm.
Everybody in the industry knows that. Everything that we do today, we talk a lot about connected machines. We talk about smart factory. We talk about being able to see what's taking place on your shop floor. Yet when we measure the efficiency or the utilization of spindles in current machine shops, we're seeing 35 to 40% spindle utilization. So a lot of people come to us and we'll talk about, why do you use a connected machine? Why do you measure things? And it all comes down to what efficiency are you driving towards, and then where are the low-hanging fruit where you can try to gain some of that back. And what I see over and over consistently is workholding. It comes down to most people in North America right now in manufacturing are doing high mix, low volume work. So
Correct.
They're constantly changing over. They do 5 of these parts, 10 of these parts. Mm-hmm. So changeover time is a big problem. And where most of their downtime comes in is when they're going from part A to part B.
Correct.
And they're taking workholding off and setting things back up. And that to me is a big part of the low-hanging fruit that we can attack from our OEM and from walking customers' floors and finding ways to do things better. What do you see? What are ways that people could approach that?
So what is super exciting for me, being, I guess, sort of a manufacturing nerd and being able to play with this stuff all the time, is we'll take the Okuma platform, for example. The controller is so incredibly powerful, and there are so many different applications that are developed. And honestly, I don't even think we've scratched the scratch on that yet. But there's some incredible applications developed for the controller. So then you couple that with some of the peripherals that are available for the machines, like probing systems. And then you combine that with a repeatable foundational element such as the ball lock system, and you have the makings of a automation powerhouse just with your off-the-shelf machine tool. And that's not talking about adding robots. That's not talking about adding really anything else. So what's incredible about that is like one of the concepts we share with customers a lot. So we have this ball lock system. We have these repeatable locations. And we know, because we face it as well, there's this skills gap out there. So, you can always have most of your day chewed up with these changeovers, as we've discussed, with these setup issues, interpretation of work instructions, all these kind of things that play on you. that eat at your efficiency. So what we try to promote to customers is, let's take these fixed locations and let's say we don't care anymore about what job we put in what location, but what we do is we put an identification feature in the fixture plate or in the work holding that's always at the same location in there. And so that when we create programs now, the first thing that happens in the program is it goes to a sub program, jumps down to the probe. The probe goes over to that feature location, probes that feature based on feature size. It does some simple Boolean logic and looks at it and goes, oh, this is job number such and such, calls the program. So now all of a sudden, if we do this correctly, we can put 3, 4, 5, 6 jobs across this table, and the operator, all they have to do is put the fixture plate in the machine, fire up the probing sequence, and it identifies what the job is, what the tool list is, what the in-process inspection features are, and everything. So now when we start talking about what the benefits are of and this is what I used to teach at the college level when we started talking about jigs and fixtures, was that the jigs and fixtures and the machine tools really transferred the skill needed by the specialized person down to the tool, right? And so now it's embedded in the tool. So that takes away some of that skill. Well, this is the same thing that happens now when we start working with our machine tool concept in this probing, is that we've taken that skill set, reduced it down to the machine. Now the machine is managing all of this for us. So, that's just with an off-the-shelf machine without spending a ton of extra bucks on stuff. And let's just say that your volumes explode in terms of the number of jobs you have after that. Well, then that's when you start to climb up the automation staircase and add pieces like robots and offline inspection equipment and so on and so forth. So, just with what's on the shelf today, someone could really explode their business just with what's on the shelf.
Yep. So when you look at a product like a ZPS, your zero-point system, do you see customers utilizing that from roughing operations, finishing operations, inspection operations? So they're loading up a part, and then that's transferring through various different processes?
Absolutely. Many of our products, our Quick Lock product, our zero-point system, they all have that capability to be utilized in, say, like a horizontal lathe environment. Then they're moved over into a 5-axis milling environment without ever letting go of the part. Then we can go on to, CMM equipment. We can go into deburr stations. There's a lot of things like that we can do. Customers are just starting now to wrap their head around that type of workflow, and it's really starting to become pretty neat. When you start to see multi-pallet machines where they have FASTM systems on the front of them and there's 40, 50 pallets, customers really like the ability to basically attach their workpiece to a tooling column, to a fixture plate with a single fastener, whether it's a screw, whether it's an air gun, something like that. So that's really appealing and really popular right now.
Mm-hmm. All right. What type of revenue, how does a customer, if he's trying to invest in new work holding, how do they realize the return on that investment? How do they realize revenue from those improvements?
Yeah. So, unfortunately today, back to that skills gap piece, many of the initial responses we get when we start approaching people about making an investment is, well, how much is it going to cost? How much more work is that going to make for me? This is from the operator side, or what's in it for me? More importantly, I think for the operator side of things. So there's a couple challenges there. There's the the whole psychology of change. Number one, number two, there's the cost, but I think that the most difficult step is when you start to probe what their OEEs are, and it comes out in the wash that they're really 25-30% is what their actual efficiencies are on their runs during the day. And a lot of people don't like to have that conversation,
right?
Because that speaks to a lot of things that are going on. So when you can tell them, listen, you're running at 30% here. If you do these simple steps, you spend this, $10,000, $15,000 investment, you could be 90%. They're like, wow. I mean, that's like a quantum leap gain. We see it all the time. I mean, we will see regularly setup reductions in the 90 percentile. We will see efficiencies go up into the 90% range. It's like anything else. You have to embrace it as a system. It's not, you can't really just pigeonhole it. You really have to start to embrace it as a systemic kind of mindset, if you will. But that's how they really start to see what's in it for them, monetarily. That's how they start to see the ROI numbers. Mm-hmm. So we can do all kind of calculations to, assist them in understanding, where they're at today, what they can do to get to here. But the magic is when we take one machine, usually we take a vertical mill, and it's usually low-hanging fruit, and we take that and we turn that into a 90%er. That's when the light bulbs go off.
Right.
That's when the light bulb goes off. And some of the battles we face with this too is really that it's really on the operator side, because the operators are very hesitant because they're like, wow, this is going to make me look bad, or this is going to make me do more work and stuff like that. And it's sort of like the conversation people have about robots, because people are afraid of robots and they're, it's going to take my job. It's going to do this for me. It makes their job easier. It makes their job more efficient. It allows them to do higher level work.
That's a big part that I think that people miss out on, is it frees you up to improve your life, frees you up to do something better, to learn, get new skills, and drive up the economic skill.
There's a soft side of that isn't even recognized past the basic ROI numbers of business. The employee actually gets to ascend to a different level fairly quickly, and really do some things that are more meaningful.
Yeah. So we're talking about skills gap. That's a big topic
Sure.
in probably every industry, but I know we feel it tremendously in the manufacturing side of things, and it's such a broad spectrum. You can talk about a skills gap, everything from programmers to work holding. But I do think that we see things, at least from the OEM side, from the machine tool side, something I see that's repeatable that I get probably half dozen calls a month on. People will call up and they've got a certain process, a certain part that they're wanting to look at. And they'll say, what kind of tolerance can I hold on this part on your machine? What's your horizontal, your 5-axis machine? How tight a tolerance can I hold on that? And my first response is, the machine tool really has a very small part of that entire process. It's much more encompassing, and I'll tend to start questioning, how are you going to hold the part? Yeah. What's your R&R on your gauge and your
For sure.
Your work holding? And most of the time, when I throw a statement like that out there, what kind of repeatability do you have on your work holding? Deer in headlights. I get blank stares, or they start shifting their questions somewhere else. Do you see that, I guess, from the work holding side? Do you run into those issues?
Absolutely. And in many cases today, they don't, that's not even asked. They don't even think of that. Typically the scenario is, here's a part, help me hold it. And I got to make a lot of them. I mean, it's really, I mean, because of the knowledge gap, it's their interest level or their questions or their inquiries are very, very basic.
All right. So how do you start? I'm Wade Anderson. I'm going to call you up. I've got this whiz-bang part that I've got to make. Jason, here's a part I got to make. Help me hold it. What's your process? How do you get started with that?
Yeah. So we do a couple things. We really like to be in the customer's facility. The phone and the email and all that stuff's fantastic, but really need to be in the customer's facility. We like to be able to look at their processes. We like to look at how they approach, metalworking now. And then from there, we get into, all the things you'd imagine about, where's the print, what are the datums, what are the tolerances, what is your expectation of throughput, what is your expectation of density, all of these kinds of things. And with the advent of all this technology, we spoke about a little bit ago how there's this transference of that specialized person to the work holding or the jig or the fixture or the machine. That phenomenon has really taken hold pretty hard in developing new work holding, in that we develop things now that really have a parameter box that they fall into. So they're going to be capable of producing this much force clamp-wise. They have this level of dynamic stiffness, and they'll hold parts to this tolerance level, right? So then if you want this kind of level of accuracy and repeatability, then we have this group of products. Then we have this group of products. So it's no longer really designing with specificity in mind like we used to in terms of here's the customer will come to you and say, I have an R&R number I got to have. This is where you got to be. And so you have to come up with a solution that fits in that box. That's really not, we don't see that anymore. And if we do see it, it's going to be with the smaller portion of the business now, which is the high volume folks. It's typically automotive, appliance, possibly electronics. But that is a smaller and smaller portion of the business today. So we really rarely get into those conversations. Now, I will tell you that my team back at the office, they understand that backwards and forwards, and they do their own due diligence and trying to understand what the material is. We really like to talk to them about programming and what their approach is to tool pathing.
Yeah. What's your strategy for removing the material? Because
we still have a lot of customers here in the States that really approach things with the I call it blunt force trauma methodology. Full depth, full width, chunka across there, and hey, we're machining.
Blunt force trauma is usually what happens when I'm running a machine. So.
Right. So it's we start talking to folks about how are they tool pathing? What's their process? What kind of software do they use? Because that's part of the game too. Because we have these canned products in these boxes, so we need to understand how they're tool pathing because not all of them are applicable. So again, back to that, we don't really design with specificity in mind. We're using a lot of off-the-shelf products today.
Right. So where do you see technology coming into play with work holding? I'll tell you, back in my day, we used to use telltale indicators. We would set up a process, run a grinding wheel across of it, and try to see how much force is being applied to the part, understand where we need to add support, how do we need to adjust the work holding, things of that nature. Is any of this taking place today electronically? Are you guys starting to see trends where you're using sensors in the work holding so you can see how much force is being applied? Does that get fed into the control for variable, processing?
Yeah. So this is absolutely on the radar with all of the monitoring tools that are available in the market to monitor the machine's performance. There's also some really sharp guys, fellow partner at Think, that does adaptive control technology, Karen Engineering. And they've really taken that to a whole new level. So for us on the work holding side, we are creating work holding with sensors in it to do exactly what you're talking about, provide a output so that it can be received and evaluated, and then we can adapt the function of the machine. So it ties directly in with what Karen does. And so we have that for location purposes. We have it for sensing. Is the vice about to give up the ghost? We know what the baseline clamp pressure is. If it starts to get really light, it's about ready to shoot that part out. So we better slow things down. We better stop. Those kind of things. On the location side, we have in development reader heads that actually go in the spindle that will traverse with basically a G-code program across the top of the table, sort of similar to the probing idea we spoke of earlier, and it'll identify what job is in the machine, at what location it's at, and load programs and things of that nature. So yeah, that is a big piece of what's going on today. There's a lot of confirmation stuff that's required in the automation side of things. So as you climb up that automation staircase, we need to confirm, is the thing clamped? Is the thing unclamped? Is the present sensors and stuff like that? So all of our work holding is already wired for that, and we're constantly in development and working with other partners trying to understand, how to, what kind of signal to output, what format it has to be in, and then what are our options in terms of, feeding back to the controller to tell it to make a change or such.
Excellent. Jason, I want to thank you for your time today. That pretty much wraps up the time we've got. I want to thank you for coming in and sharing everything you know about work holding. And for everybody listening, if you have ideas, things that you want to hear us talk about on the podcast, please reach out to us. Until then, we'll join you next time.